Interfaces are similar to abstract classes, but in this case, all the methods are abstract. Um, and similarly, we can't instantiate an interface. You have to subclass it, or you have to define a derived class from it. The interface is kind of like thought of like a contract. It shows you all the method names and parameter types that must be used between two sides. So that's what it's often thought of as like a contract. And instead of using the word class, we use the interface. So the interface has looks like this. It's public, shows interface, and then the interface name, and then all the methods within the interface are all going to be public by default. And if a class implements an interface, you must use the word implements instead of extends. And you can specify fields or data, sort of data members within an interface, but these are typically used as constants or final values. So they all are defined automatically as final static. So if you set like a bunch of constant values like these, in like these integers, that they are now all going to be treated as final static integers. And then any class that implements these interfaces will have access to these variables. So classes can typically only get derived from a superclass or a regular Java class, but Java allows a class to implement from multiple interfaces. That's another powerful feature of Java and Java interfaces. So if you want to implement multiple interfaces, you just list them one after the other with a comma. And the UML visualization for interfaces is with a dashed line. So when you use polymorphism with interfaces, this is yet another type of polymorphism. So instead of specifying a parent class, you specify the interface data type. And so you can then define a interface such as a retail item, and it can have a bunch of methods like show price, and it has maybe some parameters. And then you implement this interface. So there might be one ob object called digital song, which is an implementation of retail item, and then another object class called digital movie, which is another implementation of the interface retail item. And then you can, of course, just like interfaces, you can't instantiate a interface. You have to instantiate a class that implements the interface. And once you do create a bunch of object references to the interface, then you can invoke the methods off of that interface. So here's a case where you have a list of you have a list and you have of type interface, and then you instantiate um, objects or classes which are derived from that interface. And you can do basically a lot of sort of iterations through a list of that kind of through that iteration of that list of interface references. Again, this is another sort of implementation. Instead of an array like this, you have a list item, or sorry, an array item of interface references. So it can work just the same way like arrays, but instead with array list. Anonymous inner classes are very useful in terms of being able to define a very small, simple, special case implementation of an interface as a inner class. an inner class doesn't actually have to be a implementation of an interface. They can just be defined as a interface. So here's in a case where you have an interface called InCalculator that has one method called calculate. And inside of another class, you can actually define a uh, you can actually instantiate an object with the interface name and then actually provide the method that is defined in the interface. And you can actually define the actual behavior and the method body like this. So these are the various parts of the anonymous inner class. And then we're almost coming to the end. The interface can be used for functional interfaces and lambda expressions. So if we have a interface like this, where there's an interface with just one method, that one type of interface with just one method is called a functional interface. And then a lambda expression can be used to make things a much more anonymous. So it's basically anonymous method with no name. So here we saw that there was actually an instance, and you can see that we're still using the definitions of int calculator here. But with a lambda expression, you can just specify the parameter list on the left of the arrow and then the actual expression or the body of the code on the right side. So here's an example where the X on the left side is the parameter list, and then on the right side would be the actual expression to execute. And here is a actual implementation of that interface as a lambda expression. So you can see that X again is the input parameter, and then the right side of the arrow is the expression to return for calculate. So you can actually see here when we define the lambda function on the first line, we say int calculator square, and we set that to be that lambda expression. And then we can then use that lambda object to actually do some sort of calculation or actually execute the method.